So in the previous video we looked at how to export samples from the training dataset, from the prepared model dataset. In this video we'll look at how to use the convert weights script. So we want to reuse the weights and biases we obtained from training our model on our main machine, and we want to deploy them, use them with the NEORV32 plus NPU system. So the convert weight script does that. It extracts the model weights and biases, so from the Keras model you save and store it in an ADA specification script. And another thing that it does is, for example, for dense and convolution, where frequent multiplications are involved, it's that so for example, if you do 10 times 10, which is 100. Now for example, if there's an input layer of let's say 5 neurons and then one single output neuron, the inputs are 10 each, and there's like each connection weight is also 10. So 10 times 10 is 100, which gets stored easily in an int 8q 0.7 space of which can represent numbers between -128 and 127. So but for, if we like look at all the entire network where we have 4 neurons, so like each being like 100, input 10 and weight 10, it's like 400. The result at the output neuron will be 400 excluding the bias. So the neuron will be saturated and will only store 127, so which is wrong. We'll definitely get wrong results. So what the script does is also it uses quantization and requantization techniques learned from the GEMMLowp's guide, also linked in the main repo readme. So firstly I'll just show you how to use this script. The script is well commented enough that you can learn from it, or use ChatGPT or something, whatever that gets you, helps you. So firstly we save the model. So our model name is 28 by 28 MNIST larger model dot keras. We want to save it in a folder called exported weights q 0.7. The file name, let's just keep it 28 by 28 MNIST larger model. Let's call it test, MNIST test. Okay, MNIST test. And the package name can be MNIST test as well. You can use fstring formatting to save lines of code. This is just for demonstration purposes. So we have the input and output scale. So what we so this for specifically for dense and conv 2D layers where requantization happens, is that okay, every layer is expecting an input of int 8q 0.7 format, and therefore the output of each layer should also be in int 8q 0.7 format, because layers may be formatted in any possible way. We can't predict, okay, this will happen only like this, except for a few functional layers, possibly like softmax and sigmoid, but still anything can happen. We want to leave that flexibility, so we assume that the input scale and the output scale will always be int q 0.7. Now we extract from the model weights, we want to extract the scale and 0 point values for the model. The quantization guide explains what these values are. We want to clip values to int 8 formats. We want to quantize multipliers smaller than 1. So because int 8q 0.7 actually range is -1 to 0.99928 something, it cannot store 1 exactly. So we want to handle that case as well. This is another helper function to save write an array easily, like weights array easily. These are just weights to, okay, this is just because Python it's like uses larger precision for integers, where we only want to use a byte, because 32 because we are dealing with bytes and words in NPU and VHDL arithmetic. So we want to do that. This is packing int array to words, converting, so this is type conversion. This is helper to write an integer in ADA, because so the integers in this case we will see shortly, better to see it there. Then write ADA word array. So like like the integer array we just saw, this is word array. So it's like already 32 bits are packed as a single word in this array. Now this function was included to say that okay, so convolution has has a multi-dimensional output where we can have it's like as we saw in the MNEST thing, it was like the output shape was 26 by 26 by 14. There were like 14 output channels. Now because of these output channels, the way the filters are arranged will also vary. It's like the filter weights are arranged will vary, like for each filter as like has a kernel for an input channel. So we need to find if there was a multidimensional channel like this beforehand, so we can rearrange weights inside before exporting as exporting an ADA script. This is because the Python, because the NPU expects like okay, first there will be all the weights for the first neuron, then the weights for the second neuron, and so on. Similarly for convolution, it will be like okay, the 9 weights for the first 3 by 3 kernel, the 9 weights of the next 3 by 3 kernel, and so on. So we need to pay special attention to how weights are arranged. The comments explain that. So you may remember the fake quantization layer we introduced in the model preparation script. Now we need to have this decorator here as well, because when we load the model, the program will crash. So of course now this is just again like okay, we are writing, this is Python stuff. Okay, we need the input output helper library, which is the base library where it like provides basic read write register and functionality and such, basic data types and such. Package name is here, and this script also exports these values. So yeah, this script also generates a text file for easy viewing. So yeah, the values generated are the scale value, which is no longer used, the 0 point value, which is so better to read it from the script, from the guide, to be honest. The quantized multiplier, which will be a very large number, and the quantized right shift, which will be a small number. So after I run the script, I hope I have entered the right number. Yeah, 20. So as an end user, you only need to worry about these 4 lines. That's it. Unless you are doing something which you have not thought of during development, these are all the lines you need to worry for. So it's like okay, write your model name, the package, the script file name, and the package name. So 28 by 28. So I'll now run this script. Script ran. Params. This came due to model.summary, which is in the main program. So exported weights. This like, so it tests okay if there is like the first convolutional 2D layer. These are the biases. These are the weights, and these are the different values used. I need to read this blah blah. In the this is the generated ADA script. So this is like the package name, 28 by 28 blah. And I don't know why this okay, I think so first letter cannot be a number. I may be misremembering. Anyways, so we have these 0 point, we have the this is everything yeah, we have the quantized multiplier, we have the quantized multiplier right shift, and yeah. So we look at how to use this. So now along with the sample script, now this script needs to be again be there in your test for in your program folder. All right, thank you.